Alright, this first problem is an average speed problem. It says a caterpillar travels across the length of a 2-meter porch in 6.5 minutes. What is the average speed of the caterpillar? We don't want to know initial velocity or final velocity or maximum velocity or instantaneous velocity. We want to know what his average was over the whole time. So we take the total distance and the total time, and it'll give us average velocity. So we know that v equals d over t. But we first of all got to go from 6.5 minutes into seconds, because we always want our timing to be in seconds, our distance to be in meters, and our velocity to be in meters per second. So we do our conversion here and make sure that the units are going to cancel each other out. So we're left with 390 seconds. Velocity is distance divided by time. That's average velocity or average speed. And so it's 2.0 meters divided by 390 seconds. And depending on how you round, it's 0.00513 meters per second. Alright, problem number 2, which is number 9 on the average speed practice problem set. It says a motorist is traveling on a straight stretch of open highway, sets his cruise control at 90 kilometers per hour. How far will he travel in 15 minutes? So we want to know the distance. Distance is velocity times time. So again, we're using average speed here because he has cruise control and he's not speeding up or slowing down, so that 90 kilometers per hour is his speed the whole time, so it's an average speed. The time he traveled was 15 minutes. So because it's average speed, we can use a variation of v equals d over t. In this case, it's d equals v times t. Two conversions first. 90 kilometers per hour needs to go into meters per second, and 15 minutes needs to go into seconds. So we're left with d equals v times t. D equals 25.02 meters per second times 900 seconds, which is equal to 22,518 meters. Next one, we're talking about acceleration now. A motorcycle traveling 30 meters per second decelerates at the rate of -2 meters per second squared. What distance does it travel before coming to rest? And how long does it take to stop? This is from your acceleration practice problem set. We're looking for the time. We have a velocity of 30 meters per second when we start looking at the motorcycle and what it's doing. So that's going to be the initial velocity. The 30 meters per second is not for the whole time, it's just for that moment. So it's an instantaneous velocity. In this case, it's a VI, an initial velocity. We know it's going to come to rest, which tells us that the final velocity is going to be 0 meters per second. The acceleration is negative because it's slowing down, it's decelerating. So you put it in with a -2 meters per second squared. Whenever acceleration is negative, that means it's slowing down. Then t equals vf minus vi over a, and we get a time of 15 seconds. It'll be -30 divided by -2. So we also want to know the distance and the time. So the distance, we can do d equals vit plus 1/2 at squared. You have to be careful on this one to group these together. Your calculator probably do it right on its own, but the vi is 30 and the time is 15. So those go together first, then we're going to add them to 1/2 times -2 times 15 squared. Once you have both of those, this is going to be a negative number on this side, so you end up with 225 meters. Next one, acceleration. Jet plane traveling 185 kilometers per hour, and it is landing. It takes 36.2 seconds to come to a complete stop. What is the acceleration? So again, this 185 kilometers per hour is not an average velocity over this whole period of time. It's an initial velocity at the beginning of the time period. It's going to stop, so its final velocity is 0 meters per second. The time is 36.2. We want to know the acceleration. 185 kilometers per hour needs to go to meters per second because we always want meters and seconds. So therefore it's 51.43 meters per second. The acceleration, vf minus vi over t, we're going to end up with a -1.42 meters per second squared. Again, the reason it's negative is because the plane is slowing down. So you should get a negative number. Alright, free fall. I think there's two free fall problems here. First one, ball is dropped off a 20.5 meter roof. What's the velocity just before it hits the ground? So we don't want to know the average velocity. We don't want to know v equals d over t. We want to know vf, final velocity. So it's dropped. Even though it doesn't say the vi is 0, we should know that because it's dropped, the vi is 0. This was just like our lab. The distance is 20.5 meters, and we know that the acceleration, because it's only under the influence of gravity, it's 9.8 meters per second squared. That being said, vf squared equals vi squared plus 2ad is our only option. I'm going to do this step by step here. Vf squared equals 0 because vi is 0. Plus 2 times 9.8 times 20.5. That comes out to be 401.8. But you're not done because it's the vf squared. You have to take the square root of the whole thing. So it's vf is equal to 20.04 meters per second. That's how fast it'll be going just before it hits the ground. Last one. Skydiver jumps out of an airplane and falls 6.5 seconds before pulling his parachute. How far has he fallen? So now we're looking for distance. We want to make sure that we know we have a time, 6.5 seconds. Now let's be careful here. A lot of people want to use distance equals velocity times time. And they will put, for the velocity, 9.8 meters per second squared. Remember, that's not a velocity, that's an acceleration due to gravity. 9.8 only goes in for A. It only goes in for A in free fall. It doesn't go anywhere else. So let's see what we have. 9.8 meters per second squared because of free fall. VI, because he was starting at rest before he jumped out of the plane, is 0. Time is 6.5. D equals VIT plus 1/2 AT squared will give us what we need. And we're going to have 207.03 meters.